what we call regression techniques in statistics, right? Okay? And so how does it go? The game goes as follows. I have what I call a covariate. It's usually something that I can manipulate, I can change. In some cases, I cannot change them, but that's fine, it still works. Right? And y, x is a covariate, and y is my output. I really want to know what happened what happened to y, the response, when I increase x or I decrease x. Or x is my covariate, remember, right? So you can think what happened to someone's weight, right? Or weight circumference or whatever you want in mind when they consume more grains compared to if you don't consume more grains, for example. All right? That's the basic idea. All right, so let me come back to my problem here. And so, I told you that I have physical activity measured every minute for every individual. So I summarize this data into minute. So in a day, I have 24 hours per day, right? And every hour has 60 minutes. So how many data points that is? If you do the data, if you do the multiplication, so 24 times 60, you get 1440. But so 1440 is the number of data points I have for every individual on a specific day. So I multiply that by 5 again. So that's a lot of data. It's a lot of data. But so one way to do this is I have a regression. I can look at X being a physical activity and other covariate like gender and so on and so forth. And so once I can plug those into a regression model. But that's not really a good idea, because if you take this, once you take a regression, the classical regression, you quickly realize it's not a good idea. You have too many variables, too many x's. It's not a good idea. All right? So what happened? That's not a good idea. Big cross. Cannot do that. Next. So what I'm going to do, well, what do people do? Well, what people do is really to summarize physical activity into summary measures, right? What they get is that how much time you spend doing being sedentary, how much time you spend doing moderate to vigorous physical activity, right? That's really good. That's because remember, I told you that moderate to vigorous physical activity is really associated with the MET value. It's also associated with the level of some values from my physical activity monitor. So all I have to do, I have to put a threshold. There's a threshold above which the physical activity is characterized as moderate to vigorous physical activity. So all I have to do, I can count how much time an individual spends doing moderate to vigorous physical activity, and then include that in the problem. If you spend 0, you will have 0. You spend 10 hours, then you have 10 hours out of 24. That would be very high, right? And then I can look at other measures like what's the frequency with which I sit down and get up, I sit down and get up. So that's really what this is looking at. So this is a good idea, yeah. However, it turns out that those cut points are based on lab settings. So those cut points were obtained for individuals that were in the lab. We were in the lab and we told, okay, you're going to be in the lab, we're going to monitor everything you do. But that's not what happened in real life. Because in real life, I go to work, I got friends, I got this. So this cut point might not be appropriate for my setting. So that's the problem. Next. So what we're going to do though, we're going to look at the problem slightly a little bit different. We're going to really actually look at the physical activity, happening. Remember the funny shape I showed you earlier, where it's low in the morning, high in the day, and then come back down. We're going to do the analysis, looking at all these patterns together. All right? All right. So unfortunately, though, so if you look at this pattern here, what I have here, this pink line here, this pink color is, you can think of that's a Monday physical activity. In green is Friday physical activity, and in the middle I have all these other things, right? So next. So this is, we can do that. However, it requires something slightly a little bit technical, right? I'm not going to go through the details here, but it requires what we call functional regression, right? Because now I have it either as a covariate, but that's a little bit difficult. Continue. Now, but in reality, I want you to think back about the problem I was looking at. When I do dietary assessment, right, I have full frequency, right, and usually I have it for multiple days, right. Let me go back a little bit to dietary dietary intake study. So I have, I have a food FFQ for multiple days, right? What is it that I'm interested in? I'm not really interested in a single day intake. What is it I'm interested in? I'm interested in usual pattern, right? That's really what I'm trying to get, right? That's the same thing for physical activity. I'm not interested in a single day physical activity. Why? Because it might happen that this day I consume a lot of too many grains. But when in fact the other days I don't really consume grains, right? Really what I want to know, I'm doing the FFQ for multiple days to really try to get the true overall behavior. Does it make sense? Okay? That's really what we're doing here. What we're interested in, we really want to know the true physical activity behavior of the individual. We don't care about the days, but we care about the true physical activity behavior of the individual across the weekdays. Alright? So here you will see that I replace the curve, that the colors that I have there by a single color now. And what I call here is usual physical activity pattern for individual. Alright? Similar to what we do in nutrition studies. Okay? But another thing I'm interested in is I know that physical activity can have a different impact if you have low BMI, normal BMI, high BMI. So I'm interested in knowing how physical activity benefits an individual who happen to fall in low BMI, or normal BMI, or high BMI. Alright? So that's the slightly difficult part. Alright? Alright? And so here what we're going to do, and I think my colleague will talk a little more about it in more details. We're going to use the idea of measurement error, saying that, well, the physical activity you're interested in is really the usual physical activity, and the day-to-day variation can be due to error, like simple effect of nature, or they can also be due to device to day-to-day differences or error-induced by the devices. Alright? And so, if I want to solve this problem here, I would have to use what we refer to as compound regression. Next. Alright? And so, recapturing a little bit what is it that I said earlier. Daily work physical activity measure can be noisy measurement of the usual pattern, right? They have potential measurement error because those devices have some inherent errors that occurs daily day. And the simple average across days actually does not solve the issue. Next. Alright, so let me come back to my problem here. So similar to what I had earlier. Next. And move. So now, what I just told you about, again, remember, we really want to understand how physical activity impact. What's the effect of physical activity on BMI, right? And of course, taking into account all the other variables we have in the model. And so, once we do that, right, imagine a world where I put all of this, what I just told you about in the black box, and in the output, it gives me something like this. Next. And so, now, really what I'm showing you here is you can figure out here, I'm fitting this model, and I have this values here for low BMI, medium BMI, normal BMI, and high BMI. Right? And so I have, you can see that those estimates are sort of differing. They are different as you go from different BMI. So what that indicates here is that, the male in different BMI here we have different effects on BMI. Adjusting for all the other covariant, of course. Next. And then you can see the same thing also as I'm looking at race here, like the ethnic race. Right. All right. Next. And the second variable I'm looking at is health quality. Right? Health condition. What health condition does someone report? Right? And so you can see here that there is a difference. Depending on whether or not you're looking at lower BMI, right? You also have different effect there, right? So larger effect for high BMI and lower effect for low BMI there. That's what I'm going to say for now. And then age also. And interestingly here, age sort of have a negative effect on BMI here. All right. So next, and then to finish, one important parameter, one important quantity for our analysis is really, the effect of physical activity, right? The effect of physical. So we can think of this as effect of physical activity, and so I'm showing you here for each one of those plot here, you have sort of 3 colors there, right? So let's forget a little bit about the black color, but let's focus on the green and the red color. And so the green color is really, when you do the analysis without doing some what we call measurement error approach. And you can see that the green is always on top of red. And so that's exactly what we expect. So what happened here is that the effect tends to be a little bit attenuated, tends to be a little bit close to 0. This line here, its horizontal line is 0. And so the green is closer to 0 each one of those plots. So what that indicates is that if you don't do some interesting stuff before you do the analysis, right, your effect, it tends to be a little bit closer, it tends to be a little bit smaller, right, compared to what they ought to be if you do some statistical adjustment. All right? And then you can see here that in the morning, sort of the effect there, in the morning where there's a little physical activity, the effect is sort of flat, it gets a little bit higher, and then it gets back a little bit to being small again. All right? Yes? Now, so we did that, and so last step of our analysis was to compare what we did with the case where you fit a model where you put in your covariate the summary measures of physical activity, MVPA and ASTP, as I talked about earlier. Right? And so these here, again, how much time you spend doing previous physical activity, and ASTP is how much you spend, how much of time, what proportion of time during the day you spend being moving from up to down, right? Sedentary and active, sedentary and active, right? And so here, really what I'm showing here is that statistically, our model is better compared to a model that's sort of using only summary measure of physical activity. So in other words, if you have other things being equal, if you're interested in, if you want to report your findings, if you have a similar question than what we had today and you want to report the findings, you probably want to use our model. So that's really what this slide is showing. All right. So a few takeaways. So we provided a way to estimate the influence for the effect of physical activity pattern when the covariate are functional. So when you have physical activity pattern, you don't have self-report physical activity. You have physical activity measured all 24 hours, right? You have physical activity measured over multiple minutes. We can also accommodate the case where we have potential instrumental variable. I'm not going to get into that, but I'm happy to talk a little bit about that. It's true that, and the good thing is that we make this available so that people can easily implement the approach we propose, right? And however, they still have some difficulty in interpreting the regression model, but it's better if predictions are recorded. In some cases, that's really what we want to do. Next. Now, of course, as any limitation, right? Whenever we talk about an approach, we also got to talk about shortcomings and limitations, right? So we cannot make any causal statement here. So I cannot claim that if you do this physical activity level, then the BMI is going to be, it's really hard. I need a little, I need to perform an intervention, or I need a little more, I need to do something slightly difficult and slightly different than what I did here before I can make that statement. And maybe receiving physical activity monitor, affecting the regular physical activity pattern. Because here again, there's no control whatsoever. And so maybe people started doing a little more physical activity after we had it. And so in this case, what I'm getting here is really not a good measure of their physical activity. That other variables I know here simplicity analysis, but I guess my colleague will talk a little bit about what happened when you include those. And of course, BMI as a health outcome can be problematic, and of course, he's only US participant, right? So I think that concludes my talk, the first part. So, I'm not sure what would be the settings. So I think I'm gonna enter the mic to.
Thank you, Dr. Roger. All right, so actually I agree with you, Dr. Zoe, that having too many X's is not good. May it be in terms of variables or in terms of people, right? But seriously speaking, I think based on our National Nutrition Survey, we also have an increasing trend of physical inactivity in the Philippines, especially among older adults. And maybe we can replicate this study and see if these innovations or devices that Dr. Roger mentioned can result to a positive behavior change. No? Maybe we can explore it. So before we go to the next part of our program, let's try to incorporate some physical activity first by having an energizer to be facilitated by Miss Rose Abigail Dichasa. May I call you on stage? Hello? Alright, so before we go to the next for the next speaker, let's have a quick energizer. But before that, let me just introduce to you some of the favorite fruits here in the Philippines. So we have banana, we call it saging. Can you say it? Saging, okay. Next, mango or manga. Okay, and papaya. We call it the same, papaya. Have you tried this fruit?
Yeah.
Alright, how about the Filipino version of this fruit? Yes? Next, are you familiar with fruit salad? Fruit salad? Not here, but fruit salad. Any fruit salad?
Okay, fruit salad.
Yeah. Alright, so if we mix it all together, these fruits, whatever fruits, you can add berries, what else? Any other fruits. We have fruit salad. Okay, now for the energizer, let's give some action to these words. So let's just follow. Let me request everyone to stand up. Ayan, for a while lang, sir. Again. If the song calls for saging or banana, you raise your right hand. Saging, saging, twice. And then, manga, manga, left hand. Both hands, papaya. Papaya. Alright. And then, the paghalu-haluin or pagsama-samahin, mix it all together. What's the action for that? It's like this. Paghalu-haluin. Pagsama-samahin. And then, fruit salad. Fruit salad. Okay. Yes? Yeah. Alright, so let's play the song. Sir Paul. Right hand. Both hands. Fruit salad. Okay, faster. One more, faster.
Saging, saging, mangga, mangga, papaya, papaya, pagsama-samahin, maghalu-haluin, fruit salad.
How about sing? Talong.
Ito na pinakabilis. Saging, saging, mangga, mangga, papaya, papaya, pagsama-samahin, maghalu-haluin, fruit salad. Fruit salad.
Alright. Ma'am Rose, for that energizer. So now, I hope everybody is settled down. Do you need any health break, or do we proceed to the next speaker? Let's proceed, all right. So, let us welcome our second speaker for today. Let me introduce to you Dr. Carmen Tekwe. She is an associate professor at Indiana University in Bloomington, USA, and her research interests include statistical methodology to better assess big data such as accelerometry and dietary intake data. She is also the principal investigator of an R01 grant funded by the National Institute of Diabetes and Digestive and Kidney Diseases, focused on statistical methods for measurement error correction in device-based measures of physical activity and self-reported dietary intake. She received both her bachelor's and master's degrees in statistics from the University of Florida and earned her doctoral degree in biostatistics at the University at Buffalo. And she also completed her postdoctoral fellowship in nutrition and bioinformatics at Texas A&M University. So to discuss with us the approaches to measurement error correction in self-reported measures of dietary intake and wearable device-based measures of physical activity and obesity studies, let us give a warm applause to Dr. Carmen Tekwe.
Thank you very much for the warm welcome. Thank you, UP Los Baños, for having us here today. It's truly a great pleasure and truly an honor to be here, to be able to meet your students, your faculty, interact with you. So we really, really appreciate the invitation to come here to speak. And thank you very much for the introduction. So, thank you. My colleague went earlier and gave you an introduction to some of our work, and he talked about physical activity. I will combine physical activity and dietary intake and talk about what we've been doing with that. We're also looking at other aspects, but we're only focusing on nutrition and physical activity in today's session. So I'll be talking about correcting for measurement error in dietary intake and physical activity in obesity studies. So obesity is a problem everywhere. It's not just in the United States. It's a growing epidemic everywhere. And studies have shown that the less active we are, and also what some of what we eat can influence our propensity to either become more inclined to develop obesity over time. And so energy expenditure is something that has been shown to be related to obesity as well, but trying to actually measure or monitor energy expenditure among community dwelling adults such as you and I is very, very expensive and it's difficult. So one of the things we do, and researchers have done, is to see if they can use wearable devices as a means to try to monitor our physical activity behavior. So basically we wear physical activity monitors, and that tries to help us, give us information about our physical activity patterns. But these devices can be, while they're much better and they're easier to access than energy expenditure or using doubly labeled waters to try to obtain approximations for energy expenditure, they can also be prone to errors. And not a lot of people actually have studied this, but we know that when we use something as a proxy for something that we're really interested in measuring or monitoring, there can be a gap between what we're using to approximate the truth. So what we're doing is trying to study the difference between the truth and the proxies for it. And how many of you are nutritionists here? How many of you study nutrition? Okay, and how many statisticians do we have here? Okay, one. Oh, two, of course. Okay, so self-reported measures of energy intake are also used in nutritional studies. We want to know how what we're eating is influencing our health. And so we want to know, if we want to know how what we're eating is influencing our health, there are different ways of trying to get at that information. One way is using self-reported measures. Basically, we ask you, what did you eat? Or based on your recollection, when did you eat this? There are different formats for the questionnaires, but the idea is that you're asked or you're probed to give information about what you're eating, how often you eat it, and so on and so forth. But there are different issues associated with that. Trying to remember things that you consume every day, such as rice, might be easier. But however, if we're asked questions about things we don't consume very often, there might be recall error. For example, in the US, I don't know about here, but in the US, for something such as salmon, it's not something we consume regularly or often. And so trying to remember the last time we consumed that might be a little difficult because we don't consume it every day. But here, if we ask a question about rice, maybe because rice is consumed regularly here, you might be able to give us that information. However, what might be limited would be how much of it you're eating. So there are either issues with either over-reporting what we're eating or under-reporting what we're eating. But remember, we're trying to get this information to give us ideas of how and how much we're eating influence our health. So it's important that we try to get some accurate assessments of what we're eating. Thank you. And another issue is we're studying obesity. Most statistical methods that are designed, that you study, are actually designed to study individuals who have the average body weight. Average, the normal. As you probably, how many of you have heard of the normal distribution? Well, yeah, at some point, most of us have heard of the normal distribution. Well, the normal distribution can be used when we're interested in the average individual, the average person with a normal body weight, and so on. But what we know is that when we want to study obesity, we want to be able to look at how interventions are influencing everybody, not just individuals with the average body weight or average body type. We also want to look at the individuals on the upper end who are actually at higher risk for obesity or type 2 diabetes. And at the same time, even individuals who might be on the lower end, we want to know what's going on with them as well. So quantile regression, as Dr. Zoe talked about earlier, allows us to be able to look at how different things we're interested in, behavioral interventions, for example, how that influences the full distribution of our outcome that we're interested in. So what we know is that we're becoming more and more technically advanced. So even when we first started studying using big data in our group, we actually started with doing this with elementary school kids in Texas. And at the time, they used an armband, something that was worn on their arms. But actually, that was not that long ago, but even that technology is out of fashion now. So what I'm trying to say is that we're collecting, our society is becoming more and more technically advanced, the technology is changing, and we're collecting more and more data. But just because we're collecting more data does not mean that the old techniques that were used for more simpler data sets can be used for these more complex data that we're using. So as Dr. Zoe mentioned earlier, wearable devices lead to a lot of data. So you're collecting data perhaps every second or every minute over 24 hours, over multiple days, and sometimes even multiple times. So we have a lot of data. Can we use the same methods that we've used in the past to try to assess how these physical activity data that are obtained that give us larger data to try to assess how that influences our health? What we know is that we can't. You might have more data, but we need to do more to be able to make sense of that data. So measurement error is something that we study. And the idea really behind measurement error is very simple. We're interested in obtaining some information that might be difficult, right? It could be difficult because maybe it happened in the past and now we're trying to recollect what happened. An example of that is actually in Japan with radiation from the radiation exposure from the atomic bombs. So in that case, atomic bombs were dropped in Hiroshima and Nagasaki in 1945, and about 5 years later, individuals or researchers from the United States and Japan wanted to know how the individuals who were exposed to radiation, how did that affect their health? So now they use a 1915 Japanese census survey to try to find people who were in Hiroshima and Nagasaki at the time that the bombs were dropped, and now they wanted to use that information to try to approximate how much radiation people received from being in the city when the bombs were dropped. So you can imagine, first, this is something that was very traumatic. You might not want to remember. It happened over 5 years ago, and now you're being asked exactly what building were you in when it happened. What was your body orientation? Because when you're exposed to certain, something such as radiation, your body orientation also makes a difference. So there's recall error. Same thing with nutrition. If I'm asking you, what did you eat last week? You might be able to remember a lot of it, or maybe not a lot of it. It depends on what was going on. So we have recall error, and that is an example of what we call measurement error. We're interested in knowing true radiation exposure. True radiation exposure is difficult to measure for different reasons, so we use some kind of proxies. And the proxies that we're using is based on what people remember, the distance, and so on. We're trying to know what people usually eat, dietary patterns. But we're using information based on what people remember or might not remember, and that's leading to what we call measurement error. And so measurement error can happen when it's expensive also. For example, it might be very expensive to go through and try to interview every single person in your population or a larger sample. So for different reasons, we do have measurement error that comes into our data when we're actually looking at epidemiological or observational studies. And there are different sources of measurement error. It could be due to an instrumental malfunction or device malfunction, as Dr. Zoe talked about earlier. It could be due to observational error, sampling error. So I'll give you a quick example of this. So we were having a conversation at UP Manila on Thursday? I think on Thursday or Wednesday, yeah, Thursday. And so we talked about physical activity, and one of the researchers there asked, well, it can be very expensive to try to do a study using wearable devices and recruiting a lot of people from the Philippines. Can we try to recruit people who already have Apple Watches, right? From the population of Filipinos, can we try to recruit individuals who have Apple Watches and try to use that to give us information about physical activity, right? So there are issues with that. It's a good start, right? But who would have Apple Watches here, right? Would most people in the Philippines have Apple Watches? No, so that's also introducing another kind of error, sampling bias, selection bias. So that's not measurement error, but what I'm trying to tell you is that errors come when we're designing our studies, our sampling. Okay, so I think I've already talked about this, so we can skip this. So what happens and why is it important to correct for measurement error? It's important to do that because it improves our assessments. The bias that's introduced, we can find ways of reducing that statistically, and also it allows us to be able to make more accurate interpretations and inferences from the data that we collect. So we talked about this earlier. Dr. Zoe talked about the NHANES study earlier. So what he did was looking at physical activity among adults aged 50 years and older. We're using the same data, but from a different year, and we're looking at how fiber intake and physical activity influence the full distribution of BMI. And we want to do that. We know that dietary intake can be prone to error. Physical activity using accelerometers can also be prone to errors. Well, what are those types of errors? How can we develop statistical methods to help us improve the interpretations and the inferences that we draw from these, looking at how nutrition and physical activity influence our health outcomes? And so, we're just trying to tell you that here, a lot of research has been done with scalar valued covariates. And now, we're now using some more complex data, and we want to try to develop some statistical methods to do the measurement error correction when we have some more complex data. So I'm not going to go into the details of these slides, but for the next couple of slides, I included them. I wanted to include some equations on purpose to show you that these methods take some time to develop. We don't just come up with them out of nowhere. We need to also come up with a model. So here we have a model for our outcome, which is the first equation here. And then we also have a model for our proxy measures, the surrogate measures. We put it all together to try to see if we can improve on what we call measurement errors, which are the U's in the equation. And then, just like when you're doing something in a lab, you need to make some assumptions, or you need to have some requirements in order to use, to do your experiment, for example. So we also have some assumptions that we make. I won't go into the details, but just to tell you that we do have to make some assumptions related to how and when we can use the methods that we develop. And so the methods that we develop, the ideas are very simple. There are two types of methods that we're going to talk about. One is it's based on intuition, if you think about it. You want to measure something that you cannot see. When, for example, trying to ask individuals, what do you usually eat? Right? So you take information about something that you cannot see, but you try to use a proxy for it. And we know that that's a proxy for something that's latent. When we say something is latent, in English it means it's kind of hidden. It's not something you can see, right? So what if we have information in our data that can give us enough information to be able to allow us to see more about what is hidden? So that's a method called regression calibration. Can we have some additional information in the data to give us more information about what we want to know or what we want to study? One thing I didn't measure is that one thing I didn't mention earlier is that if we use the proxy measures as the true measure for what we really want to observe. So for example, you're really interested in usual dietary intake. Well, you use the data without any measurement error correction that you get from your data frequency questionnaires. What's going to happen is that if you don't do any measurement error correction and you use the data that you collect that might be prone to error as the covariate, it leads to bias. So what we're trying to do with these different methods is try to find additional information in the data that would allow us to reduce that bias. One method is called regression calibration, and the idea is to try to collect more data. It could be replicates, more data or replicates on what you can collect, and try to use that to get better approximates for that true covariate. Can you please change? And so this is the steps for going for doing regression calibration. But the idea is really simple. Can I take something? I collected some data. Can I have some additional data, additional information from the data to help me improve what I've collected on dietary intake? If I can do that, I then use that as a new covariate to replace the true X. Can you please change? And there are different kinds of regression calibration. We're going to employ two of them. One is the fast univariate approach, which Dr. Zode discussed, the Bayesian method. And then another one is actually a method that was developed by Dr. Zoe, one of our students, and myself, and we call that FSMI. And another method is what we call a semi-parametric method. Semi-parametric method, if you've taken statistics or if you take statistics, introduction to statistics, you're going to learn about the z-test. How many of you have heard of the z-test? Maybe, yeah. Okay, so, or the central limit theorem. Okay, anyway, so z-test or t-test. T-test, yes, okay. So t-test, we make an assumption, right? One of the assumptions is we assume normality. We make a distributional assumption. But sometimes when we assume that we know the distribution that the data come from, we may actually be limiting ourselves. So what if we can relax the distributional assumption? That's an area of statistics called semi-parametric statistics. So it's a method that is sometimes also called distribution-free methods. It's a little more flexible, but that flexibility comes at a cost of needing larger samples. So I'm not going to go into the details, but what I do want to share with you is that with the methods that we're proposing, one is a parametric-based method where we do make some assumptions about distributions, and then another one, we relax those distributional assumptions. Okay, so we do some simulation studies. Simulation, how many of you have heard of a simulation study? Okay. So simulation studies, so sometimes if you watch the news and they talk about astronauts going to where do they go, the moon, or, right? So they do simulations, they don't just go right away. They try to basically mimic the situation before they do the actual experiment. So this is the similar thing here in statistics or mathematics. We try to mimic the true setting that we're not able to collect directly and try to test our methods on the true setting. So basically we know all the things that we want to estimate, and we want to know how the methods that we're proposing perform actually with the data that we simulated. So for example, we want to know, a question that can come up with is, can we use these methods with smaller samples? So if I only have a sample size of 10, can I use the methods that you're developing for this? So we study sample sizes. What kind of structures do we need for the data? So basically we study different patterns and different properties, what we call finite sample properties of the methods that we developed using simulations. So here's what, so we looked at, so this is in the simulation, this is the truth. So we know the truth. In reality, we don't know the truth. That's why we do research, right? We do research to try to give us information about the truth. So we don't know the truth, so we try to estimate some other parameters that give us information about the truth. So the closer the different methods are to that black line, the better performing they are. So the orange line here is the method that we get without doing any measurement error correction. So the difference between the black line and the red line, or I think it might actually be orange, is what we call bias, right? It's the difference between the truth and what we estimate. So we can see that regardless of the sample size, even as the sample size is going up, that the measurement error bias, the bias, meaning the difference between the method where we don't do any measurement error correction and the truth, they don't get smaller. The bias does not go away, even if you increase your sample size. Usually, if we have some issues, for example, sometimes in statistics, we can increase the sample size to try to make our estimate better. However, increasing the sample size does not make the problem with measurement error go away. And what we also see is that we compare different methods. And the red line is what happens, let's say if we take different replicates, we have multiple measurements of the same thing, and we take the average of it and use that average as a proxy measure for the true covariate, that's still a little bit, it's a little more biased than the other methods that do some measurement error correction. So the data that I shared earlier, the graph from earlier, is with the functional covariate. It's with the data, for example, that might be a big data or data that are functions of time. So for example, if we want to look at how something such as dietary intake behaves as we increase the sample size, this is an example where we use focusing on the 50th percentile. So we see that the truth is this one. Well, there's barely any biases. It's practically zero. And the naive method is the navy, is the dark blue line. So we see that also with the scalar covariate, as we're increasing the sample size, the bias associated with the naive method, where we don't do any measurement error, does not go away. And also, this is the method based on the average. So even if we take the average of the replicates, it performs better than when we don't do any measurement error correction, but there's still a bit of bias there. And this here, I know it's a little difficult to see, but I just wanted to show you that here, the bias of the average is a little difficult to see, and so this is 0.08. So when we try to assess performance using bias, we want it to go to 0 as the sample size is increasing, and that's one way of trying to assess how good of a performance our estimator is. So what I'm trying to illustrate here is that even as we increase the sample size when we don't do any measurement error correction, that the bias does not go away with increasing sample size. And here's another example. This is only something we can study in a simulation setting. We know the structure of the error for the functional data or the big data. What if we assumed that it was incorrect? What we see here is that the methods actually are sensitive to what we assume about the structure, error structure for the data. So what we see is that if we basically assume something that's a lot more complicated than the actual structure, the performance does not, the methods do not perform as well. And that's the same thing in this table. So with our application, we have almost 1,900 subjects included in our study. They were aged between 20 and 85, and we used the data from 2005 and 2006 cycles of the NHANES. For our study, we used individuals, we included individuals who had at least 5 days of wearable device data, and the devices recorded activity counts. So we're looking at activity counts due to body movements, and the dietary intake data were collected for 2 days. So we were able to calculate the BMI because we have measurements of height and weight. And in this, in our assessment, in our analysis, we use physical activity intensity as the surrogate for true physical activity behavior, and self-reported fiber intake for usual dietary intake or usual fiber intake, and age, sex, ethnicity, and type 2 diabetes were included as our error-free covariates. About 50% of the sample were females, about 68% whites, about 10% Hispanics and Black, and then also about almost 9% others. And the average age was about 44. So just to say a little bit about the others category, and this is one of the reasons why we're here in Southeast Asia, is that a lot of our data, national surveys, when we look at Asian populations, is very small, right? So it's usually included in the others category. But the others category also include Native Americans, and there are different categories of Asians, but they're all included in one category. So we can't really tease out what's really happening within the others category. So it's important to be able to get data on other different Asian populations to really be able to study what happens within that population. And so what I just want to mention here is that if we do not do any measurement error correction, that the pattern, that's the orange line, is closer to 0. That's the same thing we've observed with the Bayesian method, which Dr. Zhou mentioned. So that's what we call attenuation. Attenuation means that we're reducing or we're making something lighter. So in this case, it means that we're trying, when we don't do any measurement error correction, we're actually we have an attenuation to 0, meaning that it's getting closer to the null, saying there's no association. And so that's also a way of masking an association that might be there. And we see that across different quantile levels, there are different patterns of physical activity. And in terms of statistical significance, we have to be careful. We need to do some additional tests. What we can say is that the different patterns are different by quantiles and also at different hours of the day, which is, we don't do the same thing over 24 hours. And this is the fiber intake, the self-reported fiber intake for the whole sample. This is when we don't do any measurement error correction, so that contains 0. So when we don't do any measurement error correction for the 25th percentile or quantile, we do not observe any statistical significance. However, after doing some measurement error correction, we do observe some statistical significance. And also same thing for the 50th percentile. When we do not do any measurement error correction, we have a null association. However, after doing some measurement error correction using one of the regression calibration methods, we do observe some error, some significance. Okay, so we decided to look at this a little bit deeper, and we wanted to see with dietary intake what happens with different age groups at different quantiles. So what we see here is that for individuals at the 25th percentile, without doing any measurement error correction, for individuals 44 years and younger, there's no statistical significance. However, after doing some measurement error correction, we do observe some significance. However, with the other age groups within the 25th percentile, we do not observe any statistical association, significant association. So basically, and also, we basically observe different patterns, eating patterns, by age groups and also by quantiles. And also between males and females, we see that, for example, at the 50th percentile, for the males, when we do not do any measurement error correction, we do not observe any statistical association. However, after doing some measurement error correction, we're able to observe a relationship, statistically significant relationship. And also similar patterns by race. And what we observe is that, for example, at the 25th percentile, for Hispanics, for example, we observe some statistical significant relationships. For non-Hispanic whites, we observe statistical significant relationships after doing some measurement error correction. And the patterns go on even with physical activity at different quantiles. We observe different patterns within quantiles, and we also observe that the different methods for error correction that perform best within each quantile and different categories are different. Okay, same thing, same pattern. So, in conclusion, what we did was we developed some methods that allowed us to do some measurement error correction when we have some more complex data for what we call functional data. An example of that would be data that we collect from wearable devices for physical activity, And then also do some measurement error correction for dietary intake data. And we looked at how these different error correction methods work when we have quantile regression. And we know that we observed that the presence of measurement error, sample sizes, and also the structures of the error terms can influence the methods that we proposed. In a nutshell, if you suspect that there's measurement error in your data, try to do some methods to correct for it. Otherwise, it can lead to inaccurate conclusions. And measurement error correction, it needs to be reasonable, meaning that the error needs to be reasonable. If you have a lot of error, like a large measurement error, then we need to look more at not just doing measurement error correction might not deal with the bias. We might need to look at how the data are collected, sampling methods, and so on. So what we also observe is that the association between fiber intake and physical activity depends on subgroups, it depends on quantile levels. And I just would like to thank some of our collaborators. Ms. Shiwei Chan is a master's level statistician who works with us and helped with the analysis. Dr. Roger Zhou is a collaborator on this project. Yuan Luan is our doctoral student who helped with the coding, and Dr. Lan Shui is one of our collaborators at Oregon State University. This work was funded by the NIH, and also Eli Lilly, which is Eli Lilly allowed us to be able to do the heavy computing needed for the methods. And so we had this picture earlier. This is some members of our group. We went out for the end of the semester to celebrate the end of the semester, and I believe that's all.
Thank you very much, Dr. Carmen, for giving us a crash course in measurement errors. And thank you very much for making us realize that even though we may have already accounted for a lot of possible sources of bias in our research, some things may still have slipped, and that can correct it. We should correct them so that they don't mask the true results of our research. Alright, so we are now going to begin the open forum, but before we call our moderator, let me just announce some reminders. So for questions for our participants here, live here, please raise your hands if ever you have questions. And to our participants who are joining us via Facebook Live, please comment down your questions and our tech team will note them and ask them in your behalf. So with that, let us give the floor to our moderator, our adjunct professor, Dr. Cecilia Cristina Aquino.
Magandang hapon po. Good afternoon, everyone. First, I'd like to thank our two guests, Carmen and Roger, for coming all the way from Clark. And from Indiana to Clark, and then from Clark to Los Baños to share their expertise with us this afternoon. I hope you all appreciate the opportunity that we have had this afternoon to at least think about measurement error in your studies on physical activity and on diet. I don't know how our statisticians feel about it, but I think of measurement error as like wearing contact lenses, and how when you wear contact lenses, you're better able to see the truth. So the degree to which the correction is needed depends on how bad your eye really is to begin with. So that's how I think about measurement error, and I thought of that analogy to help our students understand why it's important to account for measurement error. And our two speakers have just given you examples of how we can deal with measurement errors in our research. And believe me, the problems exist not only when you have too few, but also when you have too many, as both of our speakers have shared with us this afternoon. So let me start with any questions from our audience here in the room. Students, you first. Questions? What about thought?
No, actually this question came from the pre-registration form. So I think there's one question raised there, and it's about more on application of your, basically what you have shared to us in terms of nutrition. How can we really embed the statistical applications we need when we're doing nutrition studies or nutrition-related studies? Because that's really a problem, particularly for the undergraduate students, on how they can really integrate the statistical methods before even starting the data collection or while doing the proposal for their undergraduate thesis. And I think for graduate students as well, that's also a big problem. Because right now the setup is we have the advisor from the Institute of Human Nutrition and Food, and then the student will be asking for an advice or advice of a statistician from the Institute of Statistics. And I think it will really help the whole institution, including the faculty members, on how we can really embed that particular aspect, or very important aspect of research, which is statistical methods before we start with the collection, processing, and the likes. So maybe anyone, either one of Doc Zoe and Doc Carmen can answer the question. Thank you, Doc.
So the question is, even before you start with your research, how can you anticipate the ways to deal with measurement error? Right on.
Well, so I think the first, as in most of our work, right? We're not truly the first one to try to answer, or to try to work in the field, right? We usually are not, right? Like you have people who have worked in the field before, and sometimes, right, if you do a little bit of literature search, you will start to appreciate what are some of the issues with data sets in there. Right? And so that's how, it's well known, everybody talks about that, right? Food frequent FFQ are prone to measurement errors, bias people, right? That's because, so if you want to do anything on nutrition assessment, that's the first part. That's the first place you want to start. You want to understand what are the issues in where you go, right? So that you don't walk blindly in a minefield, right? So you do a little bit, you got to do research. Once you do a little research, usually those issues will pop up. I agree, sometimes people don't agree. Some people say, it's not much of an issue, But I think, first doing literature search and making sure that you get a statistician involved in your study early, right? If you think there are some issues, probably try to already approach a statistician. It seems like people talk about this issue. What do you think? Is it something I need to worry about? So for me, that would be my advice. Always do some system. Know what's already out there. What are the issues that people, so that you don't run into the same issues.
I just want to agree with Dr. Zoe in the sense that it's important to think of research as interdisciplinary. So it's important to really get a statistician involved. So for example, have a discussion that just from a simple discussion that we had at UP Manila, the suggestion of, can we recruit individuals who already have wearable devices? Just having that in Philippines, just having that conversation will let us realize, there are different models of the wearable devices, and that would affect your data. right? Fitbit collects data differently from Apple Watch. Different Apple Watch designs or models are also different. The new data that are collected by Apple Watches now are a lot more detailed than what were collected with the first models of Apple Watches. So just having that conversation with the statistician will really help to be able to see some of the nuances that go into designing a study.
This one. So I hope you're taking notes, students. So the first advice is literature search. Do your due diligence in terms of searching the literature, because so many people have gone that road before, and you can learn from their lessons or their experiences so that you don't need to repeat the same mistakes. So a very good literature search, and then find a statistical friend, a statistician friend, early enough so that they can help you. And the third is measurement matters. It matters whether what brand you're using, what model you're using, and even I think Roger started talking about that. Are you going to use a food frequency questionnaire, or are you going to use a 24-hour recall, or are you going to use digital photos, which is also something that is now being extensively studied to find out what people are eating. So that's what we want to do, right? So I think that, so that's the top 3 from our 2 experts. Other questions? Do we have questions from none from the online audience? What about, yes, Filipino lumalaban.
Hello po. Good afternoon. I think this question is for Dr. Carmen. I'd like to ask, what was the wearable device used for the study? For context, I've been a fan. I'm wearing one right now, and I've been a follower of the Samsung Galaxy Watch series watch, where they've developed drastically how they measure an individual's physical activity, even incorporating bioimpedance sensor, where it could measure the body composition, fat-free mass, and such. I'd like to ask, first of all, what is the wearable device used? Then, is it still relevant to this day, since we know that Moore's law is that growth in microchips and technological advancement is exponential? Does the data is still relevant to this day?
So let me try to address the question. Are you asking whether, does it matter what the device is considering the developments in technology? And what difference does it make if you measure it now with a more updated device compared to how it was measured before using older technology? Yes?
Yes. Thank you.
Yeah, that's an excellent question. So this is using Actigraph. So that's the research. It's a research-grade device for physical activity monitoring, and it's been updated. And so, for example, the study, the data we use is what we call a uniaxial device, but the one Dr. Zoe reported on is triaxial. So the methods have changed. However, the idea that we still have data that are large, and we don't really know if they're doing what they're accurately observing or approximating what we're interested in approximating, is still a question that regardless of the model, that question is still there. It could be something that was designed today. We still need to ask, especially if we want to use it in research that would then be used for making physical activity recommendations. We want to make sure that what's being used is accurate. For actually the more recent device that we have nationally from our studies, we do observe some measurement error in it compared to the data that I used from 2005. So the idea is still there that we're using some proxy to try to get information about some truth. So a true behavior. So there's still issues with missing data, non-work times. So regardless of the model, those are some deep issues that will affect the quality of the data. And I'll let him say a bit more because he's done a lot of work with physical activity and studying the devices.
Yeah, I think so. I think the position, right? So once you start to read the research, you start to realize that there are still a lot of controversy, a lot of issues in the research. And one of the issues even is where should the device be placed, correct? So some argue it should be placed on the wrist, other argue it should be placed on the side, other argue it should be placed somewhere on the leg. I mean, and so, and what's clear though is that the data tends to be a little bit different depending on where it's placed, any device based. Right? So, I think one of the issues with those commercial devices is that the open access is not too good. It's hard to extract the data. Once you extract the data, you have to make the data align with other devices. So we know that we measure the same thing. And so people have not, in some cases, some argue that it's not a problem. Others argue that, yeah, in some cases, measuring physical activity as precise as possible is your goal. That's still an issue. So it's still got a lot of work to do. The field is fast evolving. So I think the jury is still out on that. But one thing we know is that a simple, simply thinking about it, these devices we think are prone to measurement error because of the location of the device, because of the device malfunctioning, and so on and so forth. So,
is there a gold standard? Let me just add. Also, one thing about the device is the accuracy depends on activity. So for certain activities, the devices are much better. Well, for certain activity in approximating or monitoring physical activity, or for some activities, not so. It also depends on your BMI. It goes back to what I say, a lot of science has been designed to look at what happens to the average individual. In our clinical trials, we look at when we expose individuals to drugs or interventions, how does it affect someone who has average body weight, maybe male, and healthy. But that does not look at everybody. And the same thing with physical activity devices. It actually works better for certain body types than others. So individuals with higher BMIs, the accuracy is not as good. So those are, and that does not, whether you have a new model or an old model, that's still an issue that needs to be dealt with.
Yeah, so my question, is there a gold standard at this time about which of these wearables might be the reference for measurement of physical activity?
So I think to address the problem, we don't think about, because there's a lot of money, right? I'm going to say. And so there's a lot of money in physical activity devices. So the goal is not to get the gold standard, but the goal is to see if the device align. That's this reference right now. So what it means is, if you take your Apple Watch and someone has the actigraph, and you measure, let's say, one individual wear the same device, both devices, and you measure the same, they are the same individual, the individuals performing the same activity. So if you use the Apple Watch to measure the physical activity and use the actigraph to measure the physical, we should have strong correlation. they should be correlated because we are the same individual, we measure the same physical. So that's why we're pushing. But I don't think it's going to be a standard device. I think it's going to be more, are they aligned? Are they measuring the same thing? Is there how can I say? Are those devices measuring the same physical? Are they agreed by it? Is there a great agreement? So that's where they're going. But I don't think it's going to be a standard device because of a lot of money.
So the short answer is there's no gold standard, and that they are still evolving, I guess.
The gold standard is very expensive. It's double label water.
Ah,
But you
okay.
can't do that in a population-based.
All right. So the gold standard is double labeled water, which, as you know, is not. Yes, it's not meant for population studies, and it's also not also how will you put it? It's very expensive. It's quite expensive to do, so it's not a practical way of. Yeah. Yes, ma'am.
Hello. I think my question will be for Dr. Tekwe. You have mentioned your studies with regards to dietary intake analysis, and we do know that it is very challenging and has lots of errors. So in your experience, how would you be able to minimize, for example, the so-called pattern effect? Because in our experience with Filipinos, when you do ask someone from the class D or from the so-called disadvantaged group, they tend to be conscious and sometimes they would not present the real situation. For example, we would be asking, are you eating fruits? So there are some that will answer, yes, banana, or papaya, or ano pa yun, Ma'am Rose? Manga, so mostly banana. But there are some who would be fruitful enough. Mom, we cannot even afford buying fruits because we can only afford to buy rice and, for example, vegetables. So, or there are some, they are very conscious that I need to present something that is very healthy because I know that the dietitian will take note of that. That I am into healthy.
So the question is, how do we deal with respondent bias? Yes, ma'am.
Well, that's a reality. That's a reality, unfortunately. But I think one thing that can be done, in general, when we're designing our studies, is to really try to meet our cohort or our subjects where they are. So, for example, I'll give you an example from a study in Laos trying to address malnutrition or stunting among children. And initially, they were trying to make recommendations that they give baby food to the kids. But that's not reasonable because the way the individuals in Laos eat, they eat, once you stop eating, once you stop breastfeeding or you're able to start eating solid foods, you eat with everybody. So it's also very expensive to try to tell individuals to go buy baby food when what they can afford is rice. So in that case, we're trying to design the questions or interventions to really meet individuals where they are. So for example, there are different sources of fiber, right? They're different. It doesn't have to be the most expensive fruits. It doesn't have to come from that. You can take fiber intake from different sources and try to ask them what we call culturally appropriate questions or maybe financially appropriate questions. I don't know how to term that. But really not trying to use something that would not work or for that target population that you're interested in. You can't tell, I can't come to Southeast Asia and tell everyone, to start using baby food to address stunting, right? It's not really, it might work in the US because maybe that might be more culturally appropriate, but it might not be the way to do it here. So recognizing the population that we're dealing with and trying to make recommendations based on that. And also, in general, just to address this, is that one way and one thing that's important is to ask your question more than once. The replicates. We need replicates to be able to deal with measurement error.
Formative research for you to understand the context of your respondents can help you frame better questions so that you get the kinds of answers that we need and not the kinds of answers that the respondents will give you. Okay, before somebody else raises their hand, I want to ask my question. And my question is, I was intrigued by the fact that one of your motivations for coming here was to better understand the Asian populations in the US. And my question has to do with the appropriateness of BMI when applied, especially to the Asian context. I'm sure you're aware of this controversy. It hasn't died, it hasn't been resolved. WHO is taking a very timid approach to the issue. But as you have pointed out, it's being used globally, for good or for bad. Having worked with BMI, having worked with the diversity of populations in the US, including the Asian ones, what would you recommend to us in the Philippines? Should we use the Asian cutoffs for BMI, which is instead of 25, it's actually 23 for overweight, and the obesity is also below 30. I don't remember the cutoff anymore for obesity, but the thresholds are definitely different, and it's going to matter. When we start publishing our results, it's going to matter when we want to do comparisons across other Asian countries or with the rest of the world. What's your take on that?
Yeah, that's a really good question. It's not just Asian populations, African Americans. BMI is just not the best measure for adiposity. We use it in our applications to demonstrate the methods that we're developing, but the methods can be applied to any data that have the characteristics that of a response that's continuous. But to answer that question, abdominal adiposity is something that can be used for even just recognizing that I wouldn't use cutoff points for BMI because someone who is more athletic and who might have a higher BMI and they will be categorized as being overweight or obese, even though they're made up of all muscles. So one thing one thing is to try to see when designing studies, do we use abdominal adiposity or I don't know where. Different populations also carry adiposity in different parts of their bodies. So I don't know what it is for Asian populations, but I know, for example, one thing that we use in the US is our fat mass index. We also use abdominal adiposity. So trying to look at not necessarily BMI, we use BMI to illustrate the methods that we developed, but to really try to think more of the method that would be easy. We also want to think of not expensive that we can use. So one thing here, if we are obtaining body weight and height, can we get abdominal adiposity measures at the same time, or maybe thigh circumference, or different measures that could give us the same information that we could use as an indicator for adiposity. So that's what I would recommend. But still collect the data on BMI because it seems like everybody needs to have that in their studies. But I might not use that as a cutoff points for studies.
Yeah, just said to Dr. Tekwe, Carmen Tekwe, when they, and I've been using push to go beyond, looking at things that sort of like Dr. Kumar's way, like obese and not obese, using cutoff point. I think people really start to look at now some of the issues with BMI, where they talk about the skinny fat, and that's a term now, right? Like on the face of it, the BMI, but then waist circumference is extremely high. And so people want to look at now the sort of, combined indicators, combined sort of BMI. But yeah, for all our push here, we're looking at BMI, as an outcome here, but certainly, it can be a steady, it can be a steady to look at other type of outcomes. So, but you're right. I think on one of my slides, I looked at BMI is really problematic for some population groups.
Yes, you did. Okay. One more question, last question. Yes. There's a
Hello. Actually, it's not a question, but I just want to contextualize the question of Sir. In the Philippines, it's actually anti-graft is not really used in the research in our context. Maybe some would take that concept because mostly all the physical activity researches are more on self-reporting. Because anti-graft has been, I think, I attended an anti-graft workshop last year with Sir Jeff Pagaduan. He's an exercise physiologist at University of Tasmania. He was able to donate an anti-graft unit, actually anti-graft units in College of Human Kinetics at UPLB, and was able to learn how the anti-graft works. And unfortunately, it's not yet available in the Philippines. I think those are the first units in the Philippines, and I'm happy and fortunate that I was able to attend how it is used and how it works, from using it to the participants, to relaying or transferring the data to the computer. I was able to do more, but then just to contextualize, it's just that we do not have that yet. I think my question would be, if I have a question, would smartwatches be good tool in assessing the physical activity if we do not have actigraph? Because I think, if I'm not mistaken, actigraphs would cost in peso 25 to 30,000 per unit. That's why when we borrowed it from them, we are very careful not to drop it or anything because it's really expensive. At our level, it's really expensive, 25 to 30,000, and it's only, I think, 12
So your
units.
question is?
If the smartwatches would be okay for researchers here in the Philippines at least, since actigraph is not that used yet.
Yeah, no, I think that's a good question. So to go back to, I think what Carmen Tekwe mentioned earlier. So I think part of the research is also being people where they are and also doing with what you have. Doing with what you have. And so my take on this is, my experience, at least what I've seen, literature seems to suggest that those devices, the risk devices, are okay, and they're not perfect, but they're getting better. So I think it suggests that you could use it, but of course, there are a few things you have to be aware of: how to extract the data and how to process it. That's sometimes difficult. So, because if you use a device and then find out later on that you cannot extract the data because we don't have open source for you to do that, you stop, right? You stop. So, those are things I would make sure of first before going with those devices. I can extract the data, and I can, once I extract the data, I have, I will be able to transfer the data in a way that can give information, because what they have the all algorithm to transfer, to estimate is what. them believe, something they safeguard and not going to share with you. So before you do that, I suggest you really try to contact the salesperson and then really where you have a clear understanding that they will support you for the reason because you might run into issues. Some devices might, you might have data. How can I instruct people? Are they going to support you? Right? Otherwise, data is lost. So you want to get in touch with them and so I feel my short so yes, but you have to do your due diligence. Make sure that they know you, they're willing to support to assist you with their issues.
And I think one thing I will also add is that it's obvious that we need to study physical activity in the Philippines, Southeast Asia, West Africa, different all parts of the world. And active might be expensive for different populations too. So one thing to start with is start where you are. So that's where that conversation started with, can we recruit people who already have these devices? So one thing you want to think of is first do what we call a feasibility study or a pilot study where it might not cost as much, but you're able to show the need to do that research. So you can try to recruit even if it's 20 people, like we need to do the sample size calculation. What I'm trying to say is you don't need to try to recruit a lot of people, but recruit some people who have a certain model of the device. But recognize that there's selection bias, there's sampling error, we recognize all that, but you want to try to show proof of concept. You want to try to show feasibility that you can do that kind of study here. And then do that as a preliminary, what they call a pilot study. And then from there, you can now take it to a bigger level to try to ask for more funding to be able to study that for a larger audience.
So, thank you very much for your very active participation in our open forum. I think our speakers too, and I pass it on now to our guests.
Thank you very much, Dr. Tekwe and Dr. Carmen and Dr. Zoe. So let's proceed. By the way, if you have more questions to our participants, please feel free to write them down on your evaluation sheets, and we'll try to send them to our distinguished speakers via email if that's okay, Dr. Carmen and Dr. Zoe. So to award the certificates, may we call upon here in front our Associate Dean, Dr. Talavera, our division heads, Dr. Ning Felix and Dr. Irma Danao, and of course, Dr. Cecilia Aquin, to award the certificates to Dr. Carmen and Dr. Zoe. So let me read the certificates. With much gratitude and appreciation, may we present to you this certificate, and it reads, Certificate of Appreciation is awarded to Dr. Carmen Tekwe and Dr. Roger Zoe in grateful recognition for sharing their invaluable time and expertise as resource speakers on their respective topics held on May 29th of 2023 at the University of the Philippines, Los Baños. Signed by the IHNF Director, Dr. Amy Sherry Barion, and our Dean, Dr. Ricardo M. Sanda. Let's give them a round of applause.
User of social media. Okay, in the world, I think. So anyway, good afternoon, everyone. On behalf of the Dean of the College of Human Ecology, Dr. Ricardo M. Sandalo, we would like to thank our resource speakers, Dr. Carmen Tekwe and Dr. Roger Zoe, for their invaluable time shared with us today. We were actually having a meeting already this morning, and then this afternoon they stayed with us for the lecture. Okay, so indeed we learned a lot. It's a little bit of a nosebleed because of statistics. So our undergraduates only have one statistical course.
And our masteral and doctoral students do not actually have a statistics course. So, but we do have embedded some statistics and epidemiology as we have discussed this morning. So we also hope that our initial discussions this morning regarding our future collaborations will push through, coming from a common vision and mission. So you are welcome to visit us in the very near future, and of course for our specific activities. So we would also like to thank our participants, our undergraduate and graduate students who are with us in the live stream, our faculty, okay, and some of our reps or researchers, and those of course joining us online. We also would like to acknowledge the hard work of the Committee on Alumni International Relations, Ma'am Nika, Ma'am Ning, Sir Paul, Ma'am Ann, Ma'am Jenny, our Energizer Queen or Princess, si Ma'am Rose. They're actually our very young faculty. So our profile is we have in the 60s, faculty in the 60s, 50s, and then 30s, and then they are in their 20s. So they are our future doctoral students actually. Those are in their 30s are actually in the US, in Vienna. So we have 5 doctoral students coming from our ranks from our faculty. So maybe we can have some of them in Indiana, and even our undergraduate students think about Indiana University. So we'd like also to thank Dr. Akuin for connecting us and being with us. You know, Dr. Akuin is really very busy, and for her to, one day with us, to be with us is actually a privilege for us and an honor for us. So thank you, ma'am. And then, of course, the CHE and IHNF administrative staff. So with that, I am officially closing this seminar. Thank you very much.